All right, and we are live. So thanks everybody for joining us to the Programmability and Automation Meetup group. This is the November 29th session, and the talk today is It's Time to Rebuild DevOps. And I will turn it over to Britt and Nick, and we'll take it from there. So thanks for joining us this week.
Yeah, awesome. Nick, thanks for having us. Thank you everybody for joining. It's happy to be here. Oh, as I get my clicker right. My name is Britt Myers. I'm the VP of Engineering here at System Initiative. And Nick, I'll let you introduce yourself.
Yeah, I'm Nick. I'm a software engineer at System Initiative. Been here since it's like the second engineer to join. This meetup's a little special for me since I used to live in Durham, Chapel Hill, and RTP. Worked at NetApp out of school there for a few years, and place means a lot to me. So happy to be here.
Yeah, Nick has been with System Initiative much longer than I have. All right, so here's how we'd like to spend this time today. We'll briefly kind of recap what our journey has been through DevOps so far. We're going to talk about some of the lessons that we've learned, and then we're going to talk about what a new paradigm might look like. So I threw up just some dates here and sort of your DevOps timeline. So if we're coming up on almost 15 years of DevOps next year, there were some just interesting things for me, including now 20 years of SRE, CloudFormation there in 2011. So almost 12 years of infrastructure as code, and then much longer, obviously, for configuration as code. So it's been a journey. We've developed some amazing solutions, some amazing products, and we've come a really long way. And some of so a lot of those changes were sort of running in parallel to an overall changing business and technology landscape. And to some degree, I see DevOps as kind of a reaction or an answer to how can we support the demands in this changing landscape, right? So we're shifting from perpetual licensing to subscription licensing, on-premise to cloud, so on and so forth, periodic releases to continual releases. And all of this is some flavor of more value, faster, cheaper, more consistently, more reliably, which, if you squint, reads a lot like sort of the definition, one of the definitions of DevOps. I took this from the DevOps handbook, where we imagine a world where product owners, development, QA work together. They enable the fast flow of planned work, hundreds or even thousands of code deploys, while achieving world-class stability, reliability, availability, security, and probably lots of abilities in there. All right, so more value, faster, cheaper, consistently. So on this journey, we have learned some lessons, and I'd like to hand it over to Nick to kind of talk through what some of these lessons have been.
Yeah, so we can sort of dive into this immediately and as like a reflection of what we've needed over time as an industry, right? So you have sort of the birth of hyperscale coming out with Google, MySpace, YouTube, the iPhone sort of accelerating computing for beyond just the laptop and desktop use case for consumers, as well as a bunch of stuff happening in the data center and for enterprise as well. And there's sort of been this feedback loop between DevOps as well as back to industry needs and vice versa. And we've sort of seen some of the benefits of it arise, particularly on the product and development and delivery side. We've gotten continuous integration, small batches, smaller releases, shifting everything left, minimizing dependencies and handoffs. And what some of that has been able to do is, can we make changes quicker, faster, and in smaller chunks? Can we make them together? And what does it look like on a product development journey? You may notice some of these have sort of agile versus waterfall-y type felt bits. That's not by accident either. And from these things, we were able to garner observability and analytics from some of these products. Now that we're sort of all shifting everything left, minimizing handoffs, we were able to spend more times on, okay, now that we have some of this software as a service type application or even on-premises software that we're deploying, are we able to sort of track what we're doing more because now the productization and delivery as well as the operation sides are more co-joined? Are we able to sort of instill that from the very beginning? And then outcomes over outputs has been something that's been very interesting as well over time. Like, what does it look like when we actually deliver and develop the product in DevOps? And essentially, we've seen this sort of shift from, let me get you this one binary that is going to take like a month to build and we'll all get to this one moment, and sort of what is the outcome of the software we're developing together and how it ends up in a product. And if you progress towards the operations side, this is where things are probably a little more recognizable. I'm using kind of high level words there and like, feel good business elements. But what we've really seen, I think, is an improvement to the operations side. What was previously viewed as a cost center, something that maybe was a necessary evil, dev and ops and IT infrastructure and contention, has been sort of a combined force and ever present flow throughout the organization that we breathe and live every day. In fact, for a lot of folks at this meetup, the words on this slide are probably jumping right at you, because we were able to get improved automation by now some technology advances in virtualization and in cloud native stuff, as well as automation just in general from these practices at a human level, as well as versioning. Things are checked into source control, configuration and infrastructure code is easier to follow. Auditability and transparency comes from that as well. We've sort of developed a lot of common platforms as well. Open source helps with that. Less bespoke, I built it here for this specific customer type stuff. And from that, you get shared context and goals between developers, between IT infrastructure folks, and the sort of DevOps movement has arisen from that. And it happens at the very beginning. That's the key thing about shared goals. It's not just the end product. It's as we were building the software throughout the life cycle, what's the journey that it took to get there? And we start together to do that. And you sort of seen this platform advantage arise. We've heard of terms like platform engineering and a lot of things birthed out of the DevOps movements to sort of build common platforms, in-house clouds, Kubernetes, Docker, terms that a lot of folks are super familiar, I'm sure, here, and even things like Linux itself, all the way down to the OS level and VMware if you go back before Docker and Kubernetes. So those are some lessons we've learned and sort of things that we live by today.
And we don't want any of these to go away, right? These are all things that we've accepted that have made our lives like dramatically better than before we were leaning into some of these principles. But yet our outcomes are not what we want them to be. And that's largely due to these sort of 4 problems that we still see today. We have low intelligence across our systems, which leads to sort of a brutal context switching for engineers, operators, DevOps engineers, SREs, sort of name your title. We have incredibly long feedback loops still. Maybe they're not a year, maybe they're not 2 years anymore, but they're still far too long and kind of standing in the way of us achieving our goals. And collaboration, which somehow we've sort of accepted that exchanging tickets and PRs is a form of collaboration, but I would like to sort of challenge that and say that that's not enough and that we have not solved for collaboration. What's worse yet is that these things sort of reinforce each other, right? You can't really solve for collaboration if you have long feedback loops, because you end up with individuals who are learning lessons at different rates. Similarly, the brutal context switching is only exacerbated by the low intelligence, because you have to constantly go find and seek out the true meaning of what it is that you're looking at any given point in time. And what's worse, some of our approaches to implementing some of those lessons, whether it be how we handle automation, how we're handling versioning, are reinforcing some of these problems and sort of standing in our way of overcoming them. So all of this leads us to say it is time to rebuild DevOps. Our aspirations were right. So if we look at the sentence again, imagine a world, these people are working together, fast flow of work, hundreds of thousands. We still want to live in that world, but to do so, we must fundamentally rethink the system as a whole and stop iterating on the status quo. So if we're going to rebuild it, what are sort of the capabilities that we see as important? Here are 6 of them. There are, I'm sure, many more, but roughly these 6 we'll sort of focus on for this time. We need more real-time feedback, which is not necessarily doing something and then waiting for a pipeline is not real-time feedback. We need the ability to work within a tool together as opposed to collaborating outside of tools. We need support for day 2 operations up front and as sort of a first-class citizen and not an afterthought. We need to be able to support planned work and unplanned work because, as we know, not everything goes to plan. we need to unite sort of all of the relevant context. So if you think about what information you need in order to make a decision, how hard do you have to work to get it? It's too hard today. The answer is it's just too hard. So we need to bring that together. And we want to be able to have consistency and reuse. So think like standards and controls and whatever, paved roads, golden paths, best practices, and while simultaneously having the flexibility and control that we need to get the job done at the end of the day. In a lot of situations, those are at odds, and they should not have to be at odds. We should not settle. We should be able to support both. So if we're going to be rebuilding DevOps, let's sort of talk through specifically what this new paradigm could look like and what some of the elements are.
Yeah, so we have 4 major paradigm shifts that we're going to go over here, and there are many more, and they're all interrelated, so you might hear some repetition. But let's start with the one that caused folks to chase me with pitchforks at DevOps Days DC this year, which is if you sort of like say, hey, infrastructure is code, configuration is code, what if we switch to infrastructure as a model? What if the implications of that were not necessarily declarative infrastructure is required, but you could operate with it imperatively as well? And sort of how it works today, we could stop for a second and talk about that, is let's pretend we're using something like a provisioner, infrastructure provisioner, or something like Kubernetes with custom controllers and operators. Essentially, you, the human in the loop person, beautiful stick figure, write some code, and then the code is sent to an interpreter of some kind. This interpreter is usually some translation library, something written by the infrastructure provisioner, and then it talks to some third-party service, which says, hey, I see what you declared. I'm going to go make this real happen in the real world. And then I'm going to send back to you something that you can record for state. This is usually a status field in a Kubernetes operator, or in a provisioning tool, it's usually a state file. And the interpreter can talk back and forth with state. If you, for instance, edit something in a state field that deletes it, then the interpreter will go talk to the service and delete the thing. This is a one-way loop, and it's very good. It's proved effective thus far. But on the next slide, we'll see that there's a better way to do this. Now, the text isn't very legible in the screenshot, so bear with me for a minute. What you're seeing here is the equivalent to what we were describing as things modeled in infrastructure provisioners, Kubernetes, a lot of your common platforms you're used to, in one-to-one fashion. So there's AWS AMIs on here, Docker images, AWS region as a frame for all your AWS resources. And what we're essentially able to do is model your data center, essentially, lay it all out for you. And we're not only able to do this in a low-code ClickOps type way, but it's more advanced than that. It's one-to-one, and you can dive into it at the very raw elements and fields. So this even goes into testing it, for instance. Before, when you had to test something, you sent your changes up, they went to CI, talked to the AWS mock API, or maybe you edited a live cluster in staging. It broke, pods exploded, node exploded, you need a new EC2 instance. You brought the EC2 instance back up, it crash looped, you brought up another one, then you migrated pods, those pods crashed. It was just a mess. Who wants to deal with that, right? Over a single model change. Essentially, in System Initiative, what you're able to do is sort of take the testing and policy elements and enforce them at a code level, but not for the configuration and infrastructure itself. So when you work with the model, when you accept changes from either the real world or the model itself, you are able to sort of organizationally test where you want to be, as well as enforce where you want to be. And this is an immediate feedback loop. There's no CI in the loop that you have to go to, no desperate collaboration via PRs. This happens right in the UI, and you can do all this without going forward. So this is what we're seeing as like second wave of DevOps type moves, is like the model and its imperative nature of reflecting what the real world is versus what your model is, and that quick feedback that you're able to get based on the choices of which one you want to use. And I'll talk more about real world versus model later, but they're all kind of co-joined. So, but there's a second paradigm we have to deal with first.
Yeah, so if Nick's going to pick on infrastructure as code, I guess I'll pick on source control. And so imagine a world where instead of source control, what you have are these models, and they are aware of change sets. So super basic diagram of how source control works. You have some files, they are written in text. You can have multiple copies of them. You can save them. You can revert them. You can track the history of changes. You can diff changes across them. You can see how they sort of, move over time. You can branch, which therefore sort of lets you work in parallel. And there's like a whole lot of complex capabilities for managing conflict. What's not so great about this world is it's really only good for text. There's no context about the impact in the repository itself. You only get the text delta and not really any feedback about what that text delta means for you. Is this going to blow up everything, or is this the exact right change that I need? There's no policy embedded in the repository itself, and it's generally a real pain to automate. And I'll just say rebasing and rebasing. So what if instead you have these models, and these models are aware of the change sets? So there's sort of one head model that exists, and then you can have many hypothetical models or simulations that are sort of branched off of that one main head model. All those models can be aware of the same change set. The policy and the tests that Nick was describing are embedded in the model. They iterate within the change sets themselves. And so you can modify both the behavior that you want to see, as well as the configuration, and see how it plays out within the context of a simulation before you ever even start to go running that and making it live. So with this type of paradigm, it's a lot easier to collaborate because you get so much more context localized to what you need. You understand the impact of your changes better because of how the model has testing, qualifications, policy, and whatever else you need built in. You get that feedback right away when you make the change, not when you ask for it. We have contextual diffs. So knowing what happens if you change a single config line in a Docker file, what does that need to do downstream throughout the whole system? We'll tell you that when you make the change. Policy, as we talked about, is really easy to add. And because of sort of these contextual diffs, rebasing, merging, the question of what is the right change when there is a conflict, you have a lot more information to make the right decision, to figure out which way to go, left, right, or neither. All right, Nick, let's talk about single source of truth.
Sure. So now we're sort of loaded in with these ideas of what we're sort of seeing as the potential for second wave of DevOps is we're shifting you from infrastructure as code and configuration as code to infrastructure as model. We're getting through with the ability from source control to change sets for you to make more informed decisions about what you want to do. But what about this idea of a single source of truth? I talked about this earlier in a lot of your infrastructure provisioners and what you're working with today. It's all about essentially what you declare and things in the real world reaching a desired state. There's only one source of truth. But as we know from config drift, what can be done with systems very subtly, small changes and behavior over time, this isn't true. Your system at any point in time is not actually one-to-one with your declaration. Sure, it's mostly there, but the failure modes in very subtle ways are what sort of get us towards death by 1,000 cuts. Did we miss something in the configuration? Did something happen subtly on the other end? Is it not even being recorded by what's recorded in state on the other side? So right now, how this sort of works is you talk to your IAC platform of choice, and you want that to become reality. In Kubernetes, this would be an operator reconciling desired versus actual state. There are expedited fixes also coming from reality. Your 10x engineer, SRE extraordinaire, comes in at 10 p.m. after playing Diablo 4 for 18 hours and decides that they need to fix a bug that they just got called about. Well, that may not go through the IAC platform if it's the matter of holding up a SaaS platform versus going through that long process I was talking about before with CI. Drift is another one I already discussed at the bottom of this diagram. It more so covers the case of there are very subtle changes that happen with the infrastructure that may not even be detected by your IAC tools on the other side if they're long running. And external changes as well. Were there things that indirectly affected the reality you see? Were there other things that weren't necessarily present in the specific view you're seeing of your IAC? And single
And
source of truth has been excellent for all the things we discussed before. We just think there's an evolution and a way to do this better.
I think too, if I can add, Nick, like one
Sure.
thing that sticks out for me here is when your single source of truth is defined through an abstraction, it can never actually be a single source of truth because all it knows about is what you've told it. And so one thing that really hurts us here is like that lack of one-to-one makes it like it sets us up sort of for failure in it even becoming a single source of truth, because you're hand selecting what part of that truth you care about knowing, and you're hand selecting what part of that truth you're caring about describing and deciding and sort of pushing down the pipe.
Totally. And sort of informing that, that's actually a great transition to digital twins. So the concept, this also comes into declarative versus imperative infrastructure. If there's a human in the loop on each side, you got someone in the AWS console, they're editing tags fields of an EC2 resource, and you got something on the other side in the model, they're editing other parts of an EC2 resource. Maybe they want to add another volume or extend or shrink another one. Essentially, these actions have to do with what in System Initiative we call components and resources, model versus real world. But as second wave of DevOps goes, even outside of System Initiative, we believe this is the better way to observe everything. If changes happen in the real world versus in the model, you are able to sort of make decisions based on one or the other. Do you want your model to represent the real world or vice versa? And what we've talked about in the very first paradigm shift of testing, feedback, all that kind of stuff, you can sort of enforce these at a policy decision level. Maybe you always want the model to be matched, but maybe you don't. There are more times than you think that you may actually want the real world to be reflected in your model rather than the other way around. It's not always one way downstream, even though that might be a 90% use case. I believe there's another slide here.
Well, we move on. We'll move on to the next one. I think,
Got it.
the other thing that comes to mind here for me is it's less picking on single source of truth and maybe just sort of expanding like what is the truth that you need to be tracking, and a recognition that the truth of what you intended to exist is not enough to know about. You need to actually know what also exists at the same time. And so by bringing both of those constructs together under one model as a digital twin that is sort of mimicking both what is happening in whatever the system is that you're running, as well as what is in progress and what you want to be happening that's not currently, bringing that together again gives you the context, and gives you a more accurate picture of what reality is.
Totally. And that actually shifts into the fourth element here. All of these are interconnected. It's hard to not talk about the later ones when you're talking about the earlier ones, because you might say, well, why is that so important? It's because how it exists today is we declare a lot of our configuration and infrastructure, is what you're viewing on your screen now with Helm and Terraform, as sort of these, like, I'm going to insert these variables into these careful files. And if I use customize, then I'm going to get a big headache in the process. And what's going to happen here is you're going to have these static variables, which are checked into source control. There are those great benefits that we have currently. However, they aren't reactive to other things happening in the real world as the model and as the model changes, the real world changes. So what are we proposing for the second wave of DevOps in our paradigm shift? What we're proposing is a hypergraph of functions, the ability to essentially go from, I have an input. So for a Docker image, I put nginx in the field. And then as a consequence of that input in that model you were viewing all the way back, if I update it there, will the containers field be updated for a Kubernetes deployment or for a CoreOS instance? And in consequence, will that create and redelete the EC2 instance in the case of the AMI and CoreOS coming in from Docker image? And you have this downstream consequence of changes you make in the model or ones that the real world make that you can decide to accept or modify on your own. And what we're able to do is have hyper-informed intelligence with the system. Keep in mind, it may look like you can click around. It may look like you're just filling in fields and connecting things. But actually, when you combine this sort of imperative style infrastructure of a digital twin with the hypergraph of functions, you get something that's more intelligent than you were able to have before. Rather than tracking state in all these variables, and now you're writing Go, Python, and Rust and Ruby code and Bash a lot of the time too, to sort of stuff the right variables in the right places. You could just throw all that out and centralize your variables in a place that you can test and have policy for. And this is really the key thing that kicks everything off. It's not just the ability to model and run things twin to twin. It's the ability to not die by 1,000 paper cuts or by 1,000 cuts, so to speak, and be able to track the consequence of one change downstream all the way to how it affects the rest of your model.
Yeah, and so it's like these functions, we talk about testing within the model, we talk about qualifications in the model. These types of functions are sort of like hydrating the values that are then being set and used in APIs or what have you, CLI calls. This capability spread across change sets in these simulations where you have like a fine-grained amount of control, and you can test in tandem what the impact is of changing either A, how something is set, what happens when something is set, what policy am I flagging by pulling from this container repository versus this container repository. Like, you have all of the control to customize the behavior of the system as you need it, by leveraging the relationships that exist already, that we know exist. They just aren't reflected for us in the tools that we use. And so therefore, like, we can't see the impact of changes across related parts of the system.
That's right. You may seem downstream problems such as there's a port you want to use, but it's not available for your VPC or your network configuration for how you want to do it. And before, you may know that as an unofficial rule. Maybe your platform that you go through, it eschews that field away for you. Maybe you have something written for your internal cloud at your company that sort of works around that layer. But in sort of a second wave of DevOps type shape, whether it's system initiative or otherwise, essentially what you're able to do is you're able to detect these things at an individual field level, if you would like, or even at an entire component level, so an entire Docker image. So maybe not just the ports field, but the whole thing itself, as well as the things that it implements downstream. How are those things affected? What's the security and compliance posture? But not only that, is it even correct? I saw an interesting statistic at DevOps Day DC from one of the presenters that in their findings from all their customers that they run their clusters for it was either 500 or 1,000 clusters, 100% of them were misconfigured in some way of the Kubernetes clusters that the client hosted. And what the hypergraph of functions plus all the testing and infrastructures model, and as you can see, all four of these things are tied together, enables you to do is prevent those misconfigurations from even happening.
Yeah, part of what this shows too is when I talked about like not sacrificing control and flexibility for structure and consistency. If you're somebody who all you need to do is tell me what container you want to run, all you got to do is give me Nginx. If you're somebody who wants to know what's going to happen when I give you Nginx, you can go inspect what this function is going to do, interrogate it, and either accept it and or propose changes and modify its behavior. And so you can see how it gives you the ability to keep the interface well defined with the transparency to go and understand what is happening with that interface and not having to kind of context switch your way through that. So it's time to rebuild DevOps, y'all. Yeah. You might be surprised to hear this, but this is what we're doing at System Initiative. We're taking the lessons we've learned, the capabilities that we need, and adopting all the paradigms that we described today, and probably some that we haven't described today, into a real-time, multiplayer, multimodal reinvention of DevOps tooling. It's a power tool, and we're incredibly excited. And I personally am incredibly proud of the work the engineering team has done. And we would love for you all to join the discussion if you want. We have a Discord. Sign up and try the product, or clone the repository, because all the software is open source. And with that, I would love to open it up for questions.
The one last thing I want to say actually before questions that's like really cool about this is It's sort of like a core belief of a company full of people that have come from Chef, Rancher Labs, Puppet, and Docker, and all these other organizations throughout the years, is that we've sort of all had this core belief that we're kind of tired of what we have now, and we want to retain what we have with the first wave of DevOps and take it into the second wave. And System Initiative is an expression of that. Like Britt said, the software is 100% open source. So we're not so much wanting the community to be sold on a product so much as we want people to come and discuss, are there ways we could sort of develop into the second wave of System Initiative, whether it's us, our software, or otherwise. And you know, we're all birthed from open source. We love that element of it. And yeah, I guess I guess that one little note is like, this is really like a love letter to the things of years past, not a cold product rejection of it, and embracing of the community and everyone here. So
Yeah. So if there are questions, I don't actually know how to see them.
I do see one in chat. Nick, should I just go at it if I can read it?
Have at it.
Okay. So the question says, amazing set of paradigm shift. Very impressed. I come from the networking world. Thanks Cisco, Juniper, Palo Alto. Can SI technology be applied to physical platform on-premise devices, or is it only used for cloud? That's a really good question, and the answer is both. The answer is both. Precisely. I racked and stacked hardware at the NetApp data center. If any of you know where that is, next to Cisco and RTP. I would be very sad if it was not able to be used on-prem. So yeah, we could go into what that looks like and what it's ready for. It's definitely not production ready at the time of this recording, November 2023. But you can sort of try it for both use cases for sure.
Yeah, we're sort of we're hyper focused right now on AWS for sort of, you know, obvious reasons, but nothing about the stack that we have today is exclusive to AWS. If you can call a function in TypeScript and JavaScript, then you can drive it with SI.
And then actually that kind of leads to a follow up. Does SI work with Terraform or replace Terraform?
It can do both.
Yeah.
It can certainly do both. So, you know, you have a model, which is effectively a graph with nodes and edges and values, of which there's a hypergraph of function that runs underneath. Whatever you want to drive with sort of those functions is entirely up to you. We have not played much explicitly with like some of those use cases, but would love to sort of talk through the specifics, because there's definitely lots of potential.
Yeah. And then there are a few folks asking, you know, hey, I want to probably discuss more. Where can I join the Discord server? Robert put a link in chat to systeminit.com. That has access. It'll indirectly get you to our GitHub repo, as well as the Discord itself. Keep in mind that Discord, you don't have to discuss System Initiative. We just love DevOps builders. We're re-meeting a lot of cool folks. In fact, some RTP folks as well. Some friends from a friend from Epic Games in there who works on infrastructure as well. Yeah. So yeah, I think some questions are still coming in, but I think we're caught up right now.
Nick, I'm sorry I'm not more helpful. I can't figure out where the questions are coming from.
So
the slide that you showed earlier, you said it was hard to read. Is that your user interface? Could you talk a little bit about what's your user interface? You know, how do people interact with the product?
Yeah, I think I have it running locally. I might be able to just show you.
That would be great.
Yeah. So what you're seeing here is what we call our modeling screen. So if you think about like, what are the decisions you're making? What are the actions that you're driving? This is where all of that happens. On the top here, you see change sets. So this is a completely empty workspace. I have nothing deployed. If I want to start modeling some new architecture, I create a change set. I add a region. Let's say I want to deploy an EC2 instance in here. So you see what's happening is as I'm interacting with the model itself, every change that I make is calculating what the impact is of that change live. So it knows that because I dropped this EC2 instance in this region, I must want this EC2 instance to be deployed in this region. And this is before even setting the region, right? So I'm building the relationships up between these assets without even saying what some of the specific configuration values are. If I flip over to the customize screen, so this is sort of what this is where this is where all the sexiness lives, I suppose, to some degree. So all of the power and control lives here in terms of customizing the behaviors and the actions. So if I pull up, for example, so this is what an EC2 instance looks like right now in System Initiative. This function defines the schema for the EC2 instance itself. And so we say, hey, this EC2 instance, it needs to know about a region. It needs to know about some tags. We need to be able to define some user data. We need to pass in some security group IDs. So if you think about authoring, like a Terraform provider or sort of like whatever the abstraction is that you're writing, like this is where sort of that equivalent lives to some degree in our tool.
So how would this be generated? This is you create this text editor type thing, or is this what we're looking at? Is this programmatically created?
This what you're seeing here is a code editor, and you do it right in here.
Okay.
Do it right in here.
And to be clear, what you're looking at isn't the infrastructure as code or infrastructure as configuration. It's actually the customization of System Initiative itself. So right now we only support AWS, but let's say you wanted to support other, let's say you wanted to support other cloud providers like Azure. We have a lot of people in our Discord that are interested in that. And right now we're working on the module ecosystem aspect of System Initiative so that everybody can share their packages for different providers and stuff they want. But you could also model your Raspberry Pi or something small in your apartment or home that is a little device, so long as there's an API to talk to and you have functions, you have the ability to perform CRUD operations or something like it with the digital twin. You don't just have to model the usual things we're seeing right here. So this is the ability to customize System Initiative itself, which is really cool. And in fact, we didn't even really highlight it in the talk too much because the talk is about once you have these assets, what you do with them. But it is absolutely true that the authoring of assets and the extensibility of the API, this is sort of your equivalent to like your CRDs and stuff like that in Kubernetes, only with a lot more hand-holding. And what we're hoping is maybe this interface isn't necessarily just text in the future. Maybe you can construct assets in other ways that are a little more low-codey, or you can go all the way with that too.
So when you say asset would, because many of us are network engineers, asset, let's say a router or a switch would be an asset as opposed to something in the cloud that's an asset that's more ephemeral.
Yeah, you're totally right. I remember the word as well from working with a lot of hardware. There's definitely a little bit of a collision there. We're still playing around with the terminology, but if you want, you could model hardware one-to-one. If you want specific hardware modeling to be the case. Now, granted, there's probably a lot of intermediate hops you'd have to do, right? Like a lot of the things we're modeling today are software APIs, not necessarily so like the equivalent would be like if we're talking at more like a lower level, you might interface with an ESXi host that you talk to on some internal cloud platform, and then you deploy a VM on top of it. As far as like a networking level in the cloud would go, that would be something equivalent to what we handle with VPC, Route 53, other things of that nature, some of your load balancer stuff. But just because the platform has started with a bunch of cloud-based assets, we're using the asset to basically mean anything you want to model one-to-one that you may have previously defined as code or some configuration in software or a text editor, and now you'd rather do it in an imperative digital twin model instead. So if you were able to manage the hardware that way, I'd see no reason why you wouldn't be able to here as well.
Okay. And part of the challenge too with dealing with physical infrastructure like routers and switches is they often have very varying degrees of versions of code versions. So the API might be a little bit different, but certainly some of the command syntax or feature sets that are on different devices are different as well. So that's something else to think about as well. I think that's not quite as much of an issue in cloud deployments as what it is in physical infrastructure, things that
Yeah.
might have been around for years.
Yeah, it's interesting when you think about like modeling physical infrastructure, the digital twin vocabulary makes like slightly more sense rather than modeling virtual resources. Because if you think about how, if I don't know if anybody's familiar with how digital twins are used in other industries, like manufacturing or IoT, for example, a lot of times what they want to do is create a digital twin of a specific piece of machinery so they can run simulations about how it's going to perform under certain load, right? And so what you're doing is you're taking all of these signals from that physical device or that machinery, what have you, and then you're incorporating that in and being able to run tests on it. You can do the exact same thing here with System Initiative with hardware.
So if someone wanted to say migrate into this model and they had existing, Terraform modules they'd written, whatever that may be, that do something in a specific way that they're not ready to tackle yet, how would that work in a manner where they could import that and kind of consume those resources as necessary?
Yeah, I'll say we have an answer to this question. It's not fully implemented yet, but effectively because it's a digital twin and we're keeping sort of both sources of truth, we sort of accept the fact that we cannot control reality. Which means if you want to drive it with Terraform, great. You want to drive it with Pulumi, great. We'd love for you to continue to do that. You want to drive it with the console, great. Continue to do that. For us, it's acknowledging that because we already don't have control, you can keep doing that and you can use like sort of piecemeal consume System Initiative in the ways that you need. So for example here in, well, actually, maybe I'll do it this way. So like this EC2 instance, what you can do is you can define these custom actions that run on the resource itself. So for an EC2 instance, you can create it, delete it, start, stop, reboot, insert here, right? Add your list. So there's like certainly a world where what you can do is author these actions with resources that have been ultimately deployed originally with another tool or a human being however long ago, and still take advantage of the fact that we know it exists and be able to, run whatever behavior you want. So it's like take the imperative while keeping your declarative until you're ready to do more. Certainly feasible.
Then
Now,
Okay.
it's not like there yet 100%, right? So these are things that are very much in progress, but we know it has to be there.
eventually the goal would be something like, let's say you were ready to make that transition, and let's say hypothetically everything you were doing in Terraform was modeled on AWS. Essentially the idea would be that you could log into AWS or use a secret through System Initiative. We would have a discoverability paradigm and we would essentially be able to see everything that Terraform's doing at that point in time. So you could have a single switchover event where you actually just, okay, now I only accept things in the SI model, and by atrophy, your state files just aren't effective anymore and you can drop them wholesale. We're hoping it should be that easy, plug and play. This is stuff that's still in progress. We have some work to do first. And actually, we've already had a few community member PRs, which have been awesome. But yeah, it's
And the feature that Nick's talking about, we like sort of call discovery. It has existed in prior versions of System Initiative.
it has, yes.
So it's like we got to bring it up to this one.
All right. Any other questions from anybody on the call?
Those are all great questions, by the way. Thank you.
All right. Well, I think that wraps it up. Chat questions have been cleared. Everybody out there is silent, so we'll take that as everybody's ready to go. Thanks again for joining us. Thank you so much for presenting to the group.
Thank you for having us.
For those on the call, I will quickly drop in the chat where you'll be able to find the recording. I will get that posted ASAP, as well as links to their website, their GitHub, and the presentation content as well. And then for everybody else, we are going to take the month, although it is almost December, we're going to take the month of December off, and then we'll be back January, I believe, where are we at? January 18th. We will have Ben Novak from F5 talking about what it takes to write Visual Studio Code extensions. He's responsible for the VS Code extensions for most of the F5 products that are out there. So that'll be our next conversation in January. So with that, thank you everybody for joining us, and we'll see you in January.
Thank you.
Thanks,
Thanks
everyone.
for having us. Bye, everybody.
Thank you.